Okay, as we all know, this right here is a circle. But have you guys ever wondered what's this? This right here, it's a cycloid. The idea is that you take a circle with radius r and just let it roll. If you put a point right here, the point that's traveling right here along the way, this pathway is called the cycloid. Very cool. Today I will show you guys how to find the area and also the arc length under one arch right here. Namely, we go from 0 to 2 pi for the t. As we can see, we have its perimetry equation right here already. And we have to deal with the perimetry equation because there's no way for us to isolate the t from the x equation. There's no way for us to write this as y as a function of x. You can try. Leave a comment down below if you succeed or not. But anyway, let's take a look right here. We are going to find the area. And again, we will be dealing with this in the perimetry equation world. So I will write this down right here for you guys. Area, and this is a really famous question in calculus 2. So if you're taking calc 2, this right here is for you guys. Okay, integrating from t1 to t2, and the formula is you multiply y of t with the derivative of the x equation, and in the end, you are in the t world. And with that said, we should get the derivative. So let me just put it down right here for you guys, or girls too, of course. Anyway, look at the x equation, and the deal is that r is a circle that we use to generate that cycloid. So r is a constant. So don't let that bother you too much. If you would like, you can write down the following. We have x prime of t for the derivative. Well, you can just keep the r as r, and you differentiate the inside. The derivative of t is 1, and the derivative of negative sign is negative cosine. So we have 1 minus cosine of t like this. Of course, if you want to distribute, it's fine. And later on, we also get the derivative for y. So let me do it right now. We also need that later on. Anyway, keep the r as r. It's just a constant multiple. And you differentiate this part. The derivative 1 is 0. The derivative of negative cosine is positive sign. So this is what we have for the derivative. And of course, this is just like dx dt, and then you multiply by the dt on both sides, you get this part. That's pretty much the idea. Enough talking, here we go. Here we go, here we go. Integrating from 0 to 2 pi, and the reason that we go from 0 to 2 pi is because we set y to be 0 so that we can see when we will hit the x-axis. Right here and right here. That's the time when the time equal to 0 and the time equals 2 pi. Right? So that's the idea. Alright, so you go from 0 to 2 pi. And y of t is just that. And I will just show you guys a general form. So I will be using r. We have r times 1 minus cosine t. And we also need the x prime of t, which is just this one. Namely, we get r times 1 minus cosine of t. Very cool. You see that this and that are the same thing, huh? So that's very nice. Now let's do our usual integration. R times r is just a constant multiple, so we can take that to the outside. Right? So if you don't like the constant, just say, hey, I will meet you outside. Don't say that to people, that's not nice. But anyway, integrating from 0 to 2 pi, and again, this right here have to be the t values, which they are. And this times this, of course, is just this 1 minus cosine t squared, but the way to integrate that is you have to expand it. So let's multiply this out. We get 1, and then you have negative cosine t, and then another negative cosine t, so we get negative 2 cosine t. And lastly, this times that, we get plus cosine squared t like this. So we have to integrate this part. Well, we can integrate this, we can integrate that, but to integrate cosine squared t, this right here, we have to use some identity, namely the power reduction formula for cosine squared. And the result of this is equal to 1/2 times 1 plus cosine of 2t. Right? Again, it's just the power reduction formula for it. So let's go ahead and integrate. We will see that we have r squared all the way in the front. And let me just open the parentheses for the result of the integration. Integrating 1 in the t world, we get t. Integrating this, well, the derivative of cosine is negative sign, but the antiderivative of cosine is positive sign. So when we integrate cosine, we get positive sign. This negative 2 stays, and we get sine right here. And now, to integrate this, of course, you can just distribute the 1/2. We get 1/2. Integrating that, we get 1/2 t. So let me put this down right here. And now, we have to integrate 1/2 cosine 2t, like this, after we multiplied it. Earlier, it was just 1/2 plus that, right? Now, here's the deal. I have this constant multiple, so let me just keep it down right here. And integrating cosine, we get positive sine. And the good thing is that inside is just 2t. The derivative of 2t is just a 2. So I will just keep it as how it is. But don't forget, you have to divide it by the derivative of the inside. So the derivative, the 2t is 2. Divided by 2, you have to multiply by another 1/2, like this. So that's pretty much it. And now we will plug in. So let me just put on parentheses. We have to plug in 0, 2 pi, 2 pi go first, and 0 go next, and then everybody be happy. Okay, we have r squared all the way in the front. Perhaps, let me just do it like this way. All the way, r squared all the way in the front. Putting 2 pi into all the t's first. So it seems like we will get 2 pi minus 2 sine of 2 pi, and then we add 1/2, and this is going to give us 2 pi, and this is 1/4, and we have sine of 2 from here, but the t is 2 pi, so we multiply by 2 pi here, like this. Pretty good, okay? And this is just the first part. After we plug in the 2 pi, we will have to subtract, plug in 0. And the good thing is that everybody will be 0. But I will still show you guys all the work. Putting 0, we get 0, and then you have minus 2 sine t is 0, and plus 1/2 times t is 0, and this right here plus 1/4 times sine of 2, and the t is 0. So you have all this, guys. And then one more, like this. Cool. All right, let's see what we have. All the way in the front, we have r squared. Now, sine of 2 pi is 0, so this right here is just 0. Very nice, right? So this right here is just gone. This right here, you leave it. Sine of 4 pi is also 0. This is technically 4 pi, so this is gone. 0, this is 0, this is 0, this is 0. Very nice, isn't it? Now, here we have 2 pi. And then 1/2 of 2 pi is 1 more pi. So 2 pi plus 1 pi altogether was 3 pi. So we have r squared times 3 pi. So all in all, we can write this down as 3 pi r squared. This is very nice because we have seen that the surface area of a sphere, just like a ball, right? It's 4 pi r squared. This right here is 3 pi r squared. Very cool. The area under one arch is 3 pi r squared. Very, very cool. Now, let's take a look on how we can find the r lengths. Namely, you just want to go from here to here. So it's the r lengths, right? So, of course, we have to know the formula. I will just use capital L for the r lengths. And we have to integrate, again, t1 to t2. And if you want to see how we prove all these formulas, be sure you guys check out my other videos for it. But anyway, I'll write this down for you guys. What we need is, we need x prime, and you square that. So I'll just write this down, x prime. And you can also write down dx dt, same thing, seriously, right? But I'll just put it down like this, you square that, and we add y prime of t, and we square that. And on the outside, we have the dt. These are just the derivative from the perimetry equation, right? So dx dt, dy dt, so just like this. So now let's just go ahead and do the work. This is going to be integrating 0 to 2 pi for the t1 and t2. Let me just follow my colors over there. T1 should be 0 in red, and T2 should also be in red, which is a 2 pi. And now we have the square root. This right here is this, which is parentheses with r times 1 minus cosine t. And then you square that. And then for the second part, we add this right here is just r times sine t. And we square that. And of course, on the outside, we still have this dt. We are in the t world. Right? Now, this right here, you guys can maybe leave a comment down below and let me know. Is the integration step right here easier or harder than that one? Leave a comment down below and let me know. Right? So that way I know you are still watching. You're not just like go all the way back to the end of the video and just copy everything down. Right? Give me a timestamp right now as well. Thank you. This way I know who the true fans are, or the serious students, right, from my class. Anyway, we're integrating from 0 to 2 pi square root. And let's talk about the inside. Well, this right here we have r squared, so I'm just going to put down r squared for that. This right here we have to square that, so perhaps I'll just square it for you guys. When we take this and square it, we get 1 and minus 2 times this and that, which is 2 cosine t, right? 2 times this and that, which is this. And lastly, we have to add cosine square t, like this. That's very nice. And then as of this guy, I will have to add, let's put on adding in black, and we have r squared sine square t, like this. So this is pretty nice, I guess. Some people are going to be disagreeing with me, but yeah, whatever. Okay, here is the deal. Notice that this term has r squared, so is that. So we can, of course, factor that out. And let's do the little computations inside here. We get r squared on the very front. And we have the things in blue right here, namely 1 minus 2 cosine t. And here we have plus cosine squared t and plus, we factor out the r squared already. So here we have sine squared t, like this, right? And of course, our usual friend, cosine squared t plus sine squared t is just 1. So this is nicely equal to 1. And this is our old-time friend. 1 plus 1 is equal to 2. So this is what we have, right? So now let me write it down right here for you guys. We have to integrate from 0 to 2 pi. And we have the square root. Don't forget, we still have the square root right here. Right? Square root of r squared is just r, especially r is positive. So we know it's just innocent r, and it's just a constant multiple. Let me put the r in the front. And then this guy is still inside of the square root, right, in the blue. So we have the square root. 1 plus 1 is 2. You have to say that with authority. 1 plus 1 is 2. And then you have to minus the 2 cosine t, like this. And of course, we end up with the dt right here. And now, look at this, look at that. Yes, both of them have the 2, so we can factor that out. So we will factor that out. So we actually end up with like this. Square root, and you put a 2, and then you have the parentheses with 1 minus cosine t, like that, right? And again, square root of 2, it's a constant multiple. Take that to the front. So we have this r in red. And we have the square root of 2 after that. Let me put on r first. And then the square root of 2. And then the integral from 0 to 2 pi. And then the square root of 1 minus cosine t dt, like this. Oh my god, yes. I think this one's easier already. Okay, but we can still do this. I have done 100 integrals in one take before. This right here, it's just piece of cake. In fact, it's one of the integrals I did without a limit. Anyway, to take care of this integral, you have a few ways to do it. You can multiply the top and bottom by conjugate, but you don't have to do that. The easier way is this. So I will put this down right here for you guys. Let me make some notes. So I'll put this down right here, note. Right? So here we go. As we all know, sine squared theta is equal to 1/2 times 1 minus cosine of 2 theta. This is just the angle, this is just the power reduction formula, or you can look at this as the double angle identity for the cosine. In fact, we used that for the cosine version to integrate this part earlier. Now, you see this part has 1 minus cosine of something, and I want to end up with 1 minus cosine of t. So to do that, what we can do is we can just multiply both sides by 2 first. So I'll do that for you guys. And we get 2 sine square theta being 1 minus cosine of 2 theta. Well, here we have 2 theta, and we want to end up with just a t inside. So what should we do? Just let theta being t over 2. Excellent choice. So you are going to let theta equal to t over 2. And then you end up 2, and you have the sine square of t over 2 in the theta now. And then this is equal to 1 minus cosine of 2 times theta, again, is t over 2, like this. And of course, without any introduction, this and that will be cancelled it. So in other words, 1 minus cosine t is equal to 2 times sine square of t over 2, just like that. You know what? I should have keep it as this right here, and then you can just cancel. So let me perhaps erase this right here a little bit. Sorry. All right, here we go. Now we know for this part, okay? For this part, I didn't factor out the 2. Because for this part, we know it's just equal to this part. And you know 2 times 2 is 4. That's nice. So I will write this down right here for you guys. Again, this is the square root part. Square root right here. We have this 2 from earlier. And then for this part, we have this right here. So we multiply by 2, and we have the sine square of t over 2, like this. Whew, very nice. Now we will see 2 times 2 is 4. Instead of the square root, it's still 2. Put the 2 on the outside. So we have 2 and then the r in the front, like this. And we have to just integrate from 0 to 2 pi. Well, we took care of this right here already. Notice that we take the square root of this. Of course, the square and this will cancel out. So this and that cancel. We just end up with sine to the first power of t over 2, like this. Very, very nice. But don't forget your dt though. If you don't put on the dt, this is not nice to the integral, so that would be bad. Okay, let's see. We still have some more space. Here we have 2r, and now let's put down parentheses for the result of integration. Integrating sine, we get negative cosine. Okay, let me try again. Integrating sine, we get negative cosine. So right here, don't forget you get negative cosine, right? You get negative cosine. However, do it carefully, because the input is t over 2. The derivative of t over 2 is 1 over 2. Because you are doing the antiderivative, you have to divide it by the derivative, which is the constant. So that's how you can divide, right? That's how you can divide. Divided by 1/2 is the same as multiplied by 2. So again, if you differentiate this part, you end up with that. So this is very nice. And now we have to plug in, of course. Let me just put this down in blue, from 0 to 2 pi, like this, right? I will fit in everything right here. I'm not going to erase this. So we are going to put in 2 pi and then put in 0 and subtract. First of all, 2 times 2 is 4, but this is negative, so we have negative 4r. Right? This is negative 4r. And then let's go ahead and plug in. Let's see, we have cosine of t is 2 pi and then divided by 2. This is good, right? So this is the first part, like this. And then I have to subtract the second part. You're putting 0 in here. You're putting 0, I'm putting 0. Again, this is we'll multiply this and that already right here, okay? So here we have 0 into here. In another word, we get cosine of 0 over 2, like this. Okay? I was going to say this is not that bad at all, but I know a lot of you guys will be disagreeing with me, so I'm not going to say it. But in the end, check this out. Okay? In the end, check this out. Let me just write it down here. I know we can still see. This right here is cosine of pi, which will give us -1. So this is very nice. This right here is just very nicely equal to -1. Okay? This right here is -1. Let me just erase it better. Cosine of 0 is 1. Right? Cosine of 0 is 1 because this is cosine of 0, so this is 1. So this time is -1 minus 1, which is -2. So here we have to do -4r times -2. Right? -1 minus 1 is -2. -4 times -2, we get +8. And then the r. Oh my god, we finally done. Whew. So this right here, it's a times r. We are finally done. Ah, my god, it feels so good when I am able to fit in everything right here on just one board. So that way you guys can, come to the end of the video. And of course I have to step up like this. And you guys will be able to see everything. Right? So that's very, very nice. Okay? So -1 minus 1. Like that. It depends how you want to look at it. I think this is pretty clear. Very nice. Alright, so this is it. Hopefully you guys all like this video, and perhaps we can also talk about the surface area. If you take this arc right here, this arch or this arc, and rotate about the x-axis. But maybe you guys should try it on your own. Anyway, this right here is it. Hopefully you guys all like this video. And if you guys are new to my channel, please consider to subscribe. You guys can find a lot more math tutorial videos for you guys. Thank you guys so much for watching. And as always, this is it.